Okay, welcome back. In this lecture, I'm going to cover just one part of 10.2, which is identify what happens during glycolysis. So this lecture is just about glycolysis. It's going to be somewhat short because we'll read a lot out of the book and look more at the diagrams, but let's just get these notes out of the way here. So glycolysis is basically you take glucose, this 6-carbon molecule, and you're going to break it in half. And when you snap it in half, you are going to create 2 molecules of pyruvic acid. Now, pyruvic acid is also known as pyruvate. So if you hear me say pyruvate or you see pyruvate in your book, they are basically pyruvic acid and pyruvate. They are the same thing. Okay. Now, I want to talk a little bit about what does glycolysis mean. Let's just break down the word here. Glyco, okay, means sugar. Sugar. And lysis means to split. Sugar splits in glycolysis. So if I ever have a question about asking you, hey, what does glycolysis mean? Or what happens in glycolysis? And you say sugar splits, oh my gosh, I'm going to give you points. Literally, I'm going to give you points. Like glycolysis, sugar splits into 2. You're basically snapping it in half. Now, the thing about glycolysis is that you do make some ATP, but not a lot of it. In fact, you make 4 ATP molecules, but you have to burn a little bit of ATP to make those 4. So you end up with a net gain of 2 ATP molecules. So I will be very careful in my homework questions or test questions that says, I'll make sure I'll ask, like, what is the net gain of glycolysis? Okay, because then the answer is 2. Because you could argue, well, it does make 4 ATP, but it uses 2 ATP in the process to make the 4. So it's kind of like a business, right? You know, you run a business, you're going to have to spend a little bit of money to make a profit at the end. And that's what glycolysis does. Not only that, ATP is made, another energy molecule is made, and that is NADH, which is very similar to NAD plus in photosynthesis. They are basically the equivalent of each other, okay? So NADH is made as bonds are rearranged. We're going to make 2 of these molecules, NADH, and the NADH will go to the electron transport chain to be used later on, and we'll find out how it's used, what exactly does it do for the electron transport chain. So this is the diagram that's in your book. Okay, so here's my glucose. I'm going to burn or use 2 ATP molecules. Notice ATP becomes ADP to break it down here into these intermediate molecules, but they're unstable, and they're going to get rearranged again. And this is where I generate 4 ATP molecules during this process. I end up with 2 pyruvates or pyruvic acids that will go on to the Krebs cycle if oxygen is present. During the second stage of glucose, I'm also going to make 2 NADH molecules that will be used in the electron transport chain. So glucose is, I think, a 10-step reaction. And so like the front 5, you're using energy. Okay. And then the back half is where you make those energy molecules. Okay, so the front half you're burning energy, but then the back half, hey, we're trying to make some dough here. Now, this is a very simplified equation. On this next panel, I have the glycolysis and all of the reactions. This is more of my jam. I love this, but I just want to show you a little bit about what's going on here. So this is my glucose molecule, and you notice right away I'm going to use ATP. And ATP stands for adenosine triphosphate. It's got 3 phosphates, and it becomes ADP. Well, where did that phosphate go? Well, I'll tell you what happened to it. It got attached on right here, okay? Right here. So ATP becomes ADP, and that phosphate has attached to the 6th carbon. All of these carbons are labeled 1, 2, 3, 4, 5, 6. So now the new name of this molecule is glucose 6-phosphate, because that phosphate's on the number 6 carbon. And then it goes through some rearrangement here. Notice that we go from a hexagon to a pentagon, and then we burn a little bit more ATP. Oh my gosh, we're going to add on another phosphate this time to the 6th carbons. Now we have fructose 1,6 bisphosphate. This is an unstable molecule that, can go two ways. It can turn into glyceraldehyde 3-phosphate or dihydroxyl acetone phosphate. But if it goes this route, then it will eventually get to this G3P. In college biology, we call this molecule G3P. And this is the halfway point. So we've already used 1 ATP, 2 ATP. We burned 2, and now we're going to create ATP on this back half here. So it says that we go through an enzyme. Looks like we created electron carrier NADH, okay, carries 2 electrons. It will go on to the ETC. We create ATP here, and then 3-phosphoglycer. Okay, the thing I have to discuss, I forgot to mention this because I was like, hey, where are my 4 ATP? Okay, so this is half of this. Okay, so when this happens, this splits into 2, and imagine 2 of these going through the process. So you have to take this times 2. Okay, so I made NADH here. I got to take that times 2. So I made 2 here. I made ATP here. I'll take that times 2 because there's 2 of these molecules going through the process. And it goes through a few more enzymes. As you can see, lots of enzymes. And then down here, I made ATP. Well, this is just for one of those molecules. Well, I got to take it times 2. And then I end up with pyruvate or pyruvic acid. You know what? I'm just going to show you. Don't laugh at my tabs. I'm sorry. Definitely got a lot of tabs here. Doing a lot of research at the moment. Let's see if I can find a great image where it shows the split on both sides, just so you understand what I mean by that. Here we go. This looks somewhat. Yeah, so here's that unstable, the G3P, and so there's 2 of them going through the process to create that ATP. That's not the one I'm really looking for. My college biology book has a great one. Where you can see both molecules going through all the enzymes. But maybe if I type in glycolysis full diagram. Yeah, this one does, but it's not as pretty. But when it reaches that G3P, now you have two of everything. Okay, so that's why it looks like the accountant doesn't match up. But if you take it times 2, then it does. All right, so what are the advantages of glycolysis? Well, glycolysis is an extremely fast process, and it does this very quickly. It can take sugar and split it into 2 to make pyruvic acid or pyruvate, but it produces a small amount of ATP to keep the cell metabolism going. Another huge advantage of glycolysis is that there's no oxygen needed in this step. So glycolysis is always happening, and then if you have enough oxygen, then you can go on to make a whole bunch of ATP. And then if there's not, then we'll talk about a different pathway that those molecules like the pyruvic acid will take. But this does not require oxygen, which is a huge plus. So that's it for notes. Identify what happens during glycolysis.